Hi Algebra 2, this is Unit 6, Lesson 1, and we're going to start with a little review of quadratics. So quadratic is any equation that looks like this right here, f of x equals ax squared plus bx plus c. Right, so we used to call this a trinomial. We're going to go through factoring trinomials in this chapter, as well as quadratic formula and all sorts of new stuff as well. The only stipulation that they put in is that leading coefficient, the number in front of the x squared, so that a can't be 0, because if it was 0, then there wouldn't be an x squared term and it would just be a linear term. So without using your calculator, let's look at exercise 1, and we're going to evaluate each of the following quadratic functions for whatever the input that they give us is. So the first one on the left, I have f of x equals x squared, and I'm going to substitute in -3. So just remember, -3 is going in for x, and x is being squared. So -3 is being squared. So you do need parentheses around that. We're not using a calculator for this, but if you were using a calculator, please make sure to put in the parentheses. And if I put in 5 squared is just 25. So you got to be careful with those negatives. For b, I have g of x equals 2x squared minus 5, and I'm going to substitute in 2. Remember to use PEMDAS, your order of operations. So 2 squared is 4. I'm going to do exponents first. 4 times 2 is 8, and 8 minus 5 is 3. Then I'm going to substitute in -1. Again, the -1 is being squared. So -1 squared is +1. 2 times 1 is 2, and 2 minus 5 is -3. And h of x equals -x squared plus 4x. This time the negative's out there, but the negative's not being squared. So there's a negative, and then x happens to be -2. That will be squared, okay, but there's a negative sign hanging out in front, and 4 times -2. So -2 squared is +4, but then this negative is hanging out in front, and then 4 times -2 is -8, so that gives me -12. And then when I substitute in 3, again, the negative's hanging out in front, so 3 squared plus 4 times 3. So 3 squared is 9, but that's a -9, and 4 times 3 is 12, so that gives me 3. All right, and we'll do a little review of graphing quadratics. So that's going to give us a parabola. This is our basic quadratic, y equals x squared. So I want to create a table of values to plot, and I'm going to put in the domain is going to be from -3 to 3. So when I substitute in -3, -3 squared is +9, -2 squared is +4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. Okay, so I'm going to plot these. So I got 0, 0, 1, 1, -1, 1, 2, 4, -2, 4, and 3, 9, and -3, 9. So that's my parabola right here. Alrighty. Okay, so it's curved at the bottom. It's not a V. So I sketched that. That was part B. The turning point, that's the point right here. That's my turning point. So my turning point is 0, 0. Okay, and the equation of the axis of symmetry. So the axis of symmetry, let me get a red pen, is actually this y-axis is the axis of symmetry, that line right there. See how it's symmetrical on both sides of that line. The equation of that line is x equals 0. Okay. And then over what interval is this function increasing? Basically, it's increasing, right, I'm going to highlight it for us in yellow. It's increasing right here and then up. Okay, so it's increasing. I could either include the 0 or not include the 0. So I can say it's increasing where x is greater than 0, or I can say x greater than or equal to 0. Either one of those would be appropriate. All right, let's see what we have on the next page. So next page I have consider the quadratic f of x equals -x squared plus 6x plus 5. Using a table on your graphing calculator, determine the turning point of this function. Okay, so you want to put this into your calculator exactly the way it is with that negative sign in there. All right, and then you're going to hit second table. All right, every time I do it, for some reason the video comes off, so I'm not going to do it right here with you. But you're going to put that into your graphing calculator, y1. So I'm going to do negative x squared plus 6x plus 5. And then I'm going to go to my table. And the turning point is going to be at 314. So make sure that you can put that into your graphing calculator and you can see where that turning point is. The range of this quadratic, that's the y's. So the range is from negative infinity to 14. Okay. And then we want to graph it. So I'm going to have, let me just scoot this up a little bit. So I have 314, that was my turning point, and that's going to be right here. All right, and then I have 213, and I have 413, and then I have 1, 2, 3, 4, 5, 0, 5, 1, 2, 3, 4, 5, and I also have 6, 7, 110. And I have 510 on this side, and I have 65 on that side, and then I have -1, -2 down here, and I have it on that side too. Okay, so remember, these are always like a mirror image. There's that axis of symmetry in the middle, and make this, mine came out a little too pointy, it's hard to graph on here with this pen. It should be more curved right here. So this should be curved, not a point. Okay, so that's the graph. All right, and I should probably, your work for the graph would be to copy down the table. Okay, so we said we had -1, -2. We had 0, 5, 1, 10, 2, 13, 3, 14, 4, 13, 5, 10, okay, 6, 5, and you can see that turning point was right here, and you have like the mirror image on either side of that. Does this parabola open upward or downward? So it opens downward. Oh, why does this parabola open downward? Basically, it opens downward because that leading coefficient, that a value, is equal to -1. All right, so when a is less than 0, it opens downward. So that's something important. Whenever you have a negative x squared, then that parabola is going to be facing downwards. Between what consecutive integers does the larger solution to the equation lie? Show this point on your graph. Okay, so a solution is where it's equal to 0. So it's basically your x-intercepts are your solutions. So my solutions are going to be here and here. Now my solutions are a decimal. That's why it says between what two consecutive integers does the larger solution lie. So I'm looking for my larger solution. So my larger solution is over here. So it's between 6 and 7. Okay, again, this is just a review of some stuff that you should remember back from algebra. All right, and last one here, a sketch of the quadratic function y equals x squared minus 11x minus 26 is shown below, marked with points at its intercepts and its turning point. Use a table or a graph on your calculator to determine the coordinates for each point. All right, so the A point right here, so I'm going to put this into your graphing calculator, so everybody do that right now. All right, put that y equals x squared minus 11x minus 26 into your graphing calculator. Okay, so I'm going to do that at the same time that you guys are. I'm going to go to the graphing calculator. There we go. Go to y equals, and you're going to put in x squared minus 11x minus 11x minus 26. Okay, and then you're going to look at the table or the graph, so either one. So I'm going to hit second table. and see what that looks like. And you're looking for the x-intercepts. My x-intercepts are my zeros. So my x-intercepts are going to be at -2, 0. So if you look at your table, all right, on the table I have -2, 0. That's one x-intercept. And my other x-intercept, if you've got to scroll all the way down, you're looking for where y is equal to 0 is 13, 0. So the x-intercepts, okay, and I'll highlight those for us. These are my x-intercepts here and here. Whoops. And that's the zeros, the answer, the solution. So those are the coordinates. The y-intercept, okay, the y-intercept, so now x is 0. So I'm going to have to scroll all the way up. And x is 0 when y is -26. So that is point D on my graph. Okay, so I'll highlight that in a different color. So point D right here, that's my y-intercept, 0, -26. And then the turning point is point C. Now that one's like in between, so it depends. If you have a regular graphing calculator, you would be able to see what that is a little bit easier. If you go to change the table, okay, and it's going to be a decimal. So if you change the table and you make the table 0.1, then you'd be able to see it a little bit easier. And you can see that if you're looking at your table where that turning point is, that turning point is going to be like somewhere between 5 and 6. All right, because at 5, it's here are the 2 points. So you got 5 and -56, and you got 6 and -56. So your turning point is somewhere in the middle right there. So that's why I said change your table, and then you can look at it, and then you see it's 5.5 and -56.25. And that's your turning point. So that's C. Okay, so C is right there. And over what interval is this function positive? So this function is positive. Basically, let me get a different color right here. So this function is positive when x is greater than 13. So basically it's positive right here in orange, and on this side over here in orange. So it's positive when x is less than -2, and it's also positive when x is greater than 13. Okay, and that's it for today. Tomorrow we're going to talk about, well, tomorrow the next video will be on factoring, but we're going to practice some of this basic review that you should be familiar with tomorrow in class.